Now this illustration illustrates the show windows, and we're going to calculate the loads and find the number of outlets in accordance with NEC 220.14G and 220.43A. To the left, we have a question first. What is the lighting load for the show window based upon the number of lamp outlets in linear feet? So when we find the load in step one, we're applying 220.43A for the show window, and it's 200 VA. Times the 80 foot, we come up with 16,000 VA. We said it was continuous. In other words, it could burn for 3 hours or more without any kind of a contactor shutting it down or whatever. It might burn all night. See? So it's 125% for the service, 230.42A1, or for a feeder. So 125% of 16,000, we come up with 20,000. So the lighting load is 20,000 VA. It would be basically our calculation. Now, going over to the number of outlets, we have a 771 lighting outlets in accordance to 220.14G, 12,780 after we do the math. Step two now, we have the 12,780 times 125%, we come up with 15,975. So our lighting load has to be the greatest between the 200 square foot or the number of outlets. So the first step 1 and 2 in solution to the left of the boxed in information produces the greater lighting load of 20,000 VA. It's greater than 15,975, so that is what is selected. And the note naturally says the 20,000 VA calculation is used because it's greater than 15,975. But say that the calculation to the right, based upon the number of outlets, come up to 22,000, then it would be greater than the 200 VA per linear foot, so it would be used. So what is this saying? Use the larger between the two. Either the 200 VA per linear foot or the 180 VA per outlet times 125%, whichever produced the largest load. And that's what this illustration is illustrating.